welcome back. So here we do water resources, which, despite the kind of serious image, is kind of a fun, entertaining unit. Not mathy, not a lot of technical stuff, and I get to tell some funny stories along the way, so everybody wins. All right, the first part of it, we do have to talk about the basics of irrigation, reclamation, what those are, what they aren't. We'll look at some societies throughout history, right? Old ones, new ones, and how they use water. And the problems. We'll talk about how those societies have either transformed or went extinct, which is the norm. And then finally, we will look at water resources in the American West and a little bit of American history, like speed run time, and then water in Arizona. So let's get to it. We got 4 sections: irrigation and reclamation. This is more of our basics unit. We go to Egypt as a case study, water in the American West with a story, and then water in Arizona, where I get to talk to you directly, which I like. Okay. So first thing, irrigation and reclamation. So here we have the start of civilization. And by civilization, I mean people building up permanent settlements and not just moving around as hunter-gatherers, right, as nomadic people. All of a sudden, due to the invention of agriculture and the digging of canals to be able to harvest rainwater, right, people are able to stay in one area for a long time, build up cities, begin to trade with each other, and we're off to the races, right? This is our so-called Fertile Crescent, which really should extend up this a ways, the Tigris and Euphrates rivers, and then the Nile in Egypt. Everything in green, apparently, is where we want to focus on. Notice that the green and the rivers are the same. Yeah, maybe 10,000 BC is when agriculture is developed. Maybe 6,000 BC is when we have our famous cities and irrigation societies, including towns you've probably heard of, right? Gilgamesh and Ur, right? Sargon and Akkad conquering the whole world, and Babylon of Hanging Gardens fame and biblical fame as well. So these are the Tigris and Euphrates rivers. So to clarify, right, this area of Mesopotamia, which is now the Middle East, is this area. We're in the same spot here, the Persian Gulf in the southeast. Awesome. What do these look like? So this is kind of an artist depiction. It was really hard actually to find photographs of these, at least for me. Notice we have canals, right, which are able to move water from the river and distribute it to the farm. And we've got permanent settlements as a result. Be aware also, right, when we kind of imagine these canals, we want to imagine unlined canals, not modern concrete or anything like that. Like digging a hole that's long, almost like a trench, more so than what we would think of in Arizona as being like a modern day canal. And that distinction is going to be important. Definitions. What is reclamation? Taking back water, like literally reclaiming it back from the earth, collecting rain from a wide area, and then irrigation, right? We're channeling the water to where we want it. We're moving it so that it can go to all of these different farms so that we can grow enough crops to eat and go sell your surplus at the market and use the money to buy okay, right? We're channeling it, right? Channel is like this narrow, confined area that it has to move through, almost like, you know, a narrow river channel, tight and fast. So between the two, we are gathering water from a large area, storing it up, and then moving it to where we need it. And because of this process, you can farm areas that don't normally receive enough rain to be farmable, because you can collect it from elsewhere and put it to where you need it. So in that sense, we're able to grow food, and that is awesome. But there's problems, right? So every single irrigation and reclamation society or civilization that has ever existed went extinct and collapsed, got obliterated in some form or another, except for 2, which are 2 that we're going to focus on, right? What are the problems with doing this, right? With reclaiming water and irrigating? There are 3, right? Silt, salt, and stupidity. The first 2 are maybe solvable. The last one, you tell me. So the first is silt. We talked about this a bit with soil and soil textures, right? So this is kind of a visual. I mean, we know sand, right? And maybe we know something about clay. Silt is kind of in between the 2. Hard to think of a time when we would encounter this in daily lives, but it feels almost smooth, or like silky is the best way to describe it, right? This stuff almost at the top, right? You put it all together and you get loam, a loamy soil, which is the very best stuff, right? It is got enough sand and enough big particles to where water can move through it and it doesn't get bogged up and start to rot. But at the same time, you have enough clay and silt in there to where it holds on to water and moisture and doesn't just dry out, right? And you get a mix of all these three things and you get soil. So what's the problem? Why is this a bad thing? Well, we need to kind of get a visual on the different particle sizes here, right? So a piece of gravel, right, like little gravel or aquarium gravel, fish tank gravel, or like we use for the stream tables, right, is this big. Notice that sand would be about here, a grain of sand, but that silt and clay are like way smaller, right? Clay being so small that you can't even see it with a microscope if you were to zoom in. These tend to build up in canals over time, right? It's a universal thing. So as it turns out, the sand is actually able to move pretty well along the bottom over time, right? It kind of rolls along on the bottom of the canal. And the clay particles are so light and tiny that due to all the little, eddies and vortexes and all these different things just kind of get caught up in the wind inside the water, right? And roll along, and you don't have to worry about clay building up. But silt doesn't do either of those things. It's not big enough to roll along the bottom, but it's not small enough to where it just gets carried away like dust in the wind. And so it builds up over time, right? We have some photos of people in the modern day clearing silt out of canals. This is a forever problem with these things, right? They tend to build it up. Clearing this by hand is extremely costly, takes a lot of energy. Famously, this is Alexander the Great. Took him an army of 10,000 men and 3 months to dredge the silt out of a single canal in the Middle East, which was clogged up. Not a good process, right? Just to get a visual, so this thing is really building up with silt. This is not good, whatever canal this is, right? Modern day ways of dredging this out are hugely expensive as well. I mean, you can imagine how many bulldozers, if your canal is however many hundreds of miles long, all having to clear this stuff out, and it keeps building up. It's expensive, and part of why these societies tend to collapse, and another part is this, right? So if we took some salt water, right, and you just let it evaporate over time, the salt doesn't, disappear out of the universe. It doesn't get annihilated. It's still in the salt water as these little particles called ions. And as the water evaporates, the salt is left behind, and you get something really nasty like this, which you don't want. Well, even though this is going to be fresh water in rivers, not salt water, but fresh water being used for agriculture, this process still tends to happen, albeit kind of slowly, right? So salt builds up over time as these fields are flooded, which is just how big fields and irrigation works, right? It is flood watering, where they flood the whole thing under feet of water. You might have noticed at different points that like the units for water, right, like in the Colorado River is allocated in terms of acre feet. This is why that is, right? An acre foot of water is enough water to cover an acre's worth of crop with water that is a foot deep. That is why those units were used and still are used today, right? But the problem with this, right, is whenever it evaporates, just like here, it leaves salt behind, and now you have this really salty field, and the plants don't like it, right? The salt robs them of moisture, makes it really hard, which actually makes you need to put even more water in, right? Because the salt is going to absorb some of the water. So now you have to add more and more water over time in order to recover the effects of the water that you just added, right? And you can see how this kind of leads to a buildup of problems until everything comes crumbling down, right? Example of a place that has gone through saltation and is just really nasty, right? You can't grow crops here anymore. This is basically ruined unless you want to like tear everything out and start over, but that's expensive, right? Third problem. So to manage these canal systems, right, and to dig them and to figure out what water belongs to who and who needs it the most and, what happens if this person is taking water that they shouldn't be taking, right? You need organization, right? You need some sort of government or some sort of cohesive societal structure for being able to act collectively. Water presents collective action problems. They need collective action solutions in the form of organized decision-making, which leads to that last problem, right? So silt, salt, and then stupidity. Now, that's not saying that these people are stupid. That's just saying that we don't know what the future holds, and it's inevitable that people will make mistakes, right? And so you wind up with these sort of chain reactions, right? So because you have to continuously add more and more water, you need more and more water out of the canals, which means that you need to get the canals at this steeper angle, right? Which also helps with the sill not to build up so much because now it's steeper, but now you're eroding the banks, which leads to flooding elsewhere, which means that there's less water available to go and flood the fields that are salty, and they're salty because you were flooding them with so much water in the first place, and now you've got political issues because one person's field got ruined by the flooding. Okay. For all sorts of reasons, cutting across time and space and everywhere, all of these irrigation and reclamation societies fail and die, except for two, right? And one of them that did fail was this group, right? This is the ancestral Oakham people, who are the ancestors of the modern day Salt River, right? Or they considered these people to be their ancestors. Historical record keeping is really shoddy on this, and there's a lot of complications and a lot of people who would disagree with everything I said, but that seems to be the consensus. But those, ancient Native American people who live where we live were canal builders, right? And they built canals in pretty much the same places that we build them today, right? So the black lines are the old canals, and then the little dots are little sites along the way, right? And they pretty much map out to the same as our modern canal systems. They eventually collapsed, right? Maybe for these reasons, and maybe in combination with others, like drought or disease or war. But like every other irrigation society, they collapsed, right? There are two that didn't. One of them is Egypt, the other is you. We'll start with Egypt in the next section.